This is an absolute masterpiece of mechanical design, and it's hidden right inside the compact housing of the starter itself. It consists of a central sun gear, an outer ring gear, a carrier, and a set of smaller planet gears revolving right around the center. Now, planetary gears are uniquely favored by engineers because they offer incredibly large gear reductions in a highly limited space, all without adding any significant weight to the vehicle. It is the ultimate hidden strength multiplier.
Now, what's really interesting about this is how these specific components interact to multiply the motor's power. The outer ring gear is locked and firmly fixed in place. The central sun gear acts as the input, taking the high-speed spinning force directly from the electric motor. Finally, the planet carrier, which houses those revolving planet gears, serves as the output, sending a slower but massively stronger force straight out to the pinion.
This specific planetary arrangement inside the starter provides an additional gear reduction ratio of 7-to-1. So think about what happens when you combine this massive 7-to-1 internal boost with the 15 to 20-to-1 boost already waiting at the flywheel. The whole system finally creates enough sheer, overwhelming torque to forcibly spin the heavy engine block and successfully trigger combustion. Pretty amazing, right?
Section 5. Preventing motor destruction.
Okay, so the very moment the engine successfully fires up and roars to life, we instantly face a new, highly dangerous engineering problem. Under normal, everyday safe operations, human reflex takes over, right? You hear the engine start and you let go of the key. Releasing the ignition switch breaks the small electrical circuit, which de-energizes the electromagnet in the solenoid. A return spring then forcefully pulls the plunger and the pinion gear backward, simultaneously breaking the high-current electrical circuit and safely disconnecting the tiny motor from the roaring engine.
But what happens when things don't go perfectly? Well, if the operator fails to release the ignition switch the exact moment the engine starts, the flywheel will actually drive the pinion way too fast and severely damage the motor. This is a catastrophic mechanical threat known as backdrive. A running car engine spins at thousands of revolutions per minute. If it stays physically connected to the tiny starter, it's going to push all that multiplied energy backward through the gears, literally tearing the starter motor apart from the inside out. Not good.
So, to ensure human error doesn't destroy the engine's components, engineers added one final brilliant failsafe, the one-way clutch. Let's break down the mechanics here. Step 1, when the starter is doing the heavy lifting, its outer race rotates. Step 2, internal steel rollers get wedged and trapped against an inner race, firmly transferring power out to the pinion. But here is the genius part. Step 3, the literal moment the engine actually starts, it begins overdriving the pinion, spinning it much faster than the starter motor is pushing it. Step 4, this immediate shift in speed causes those internal rollers to instantly slide back and release their grip. This completely stops the physical power transfer. So even if you accidentally hold the key turn for far too long, this clutch simply slips, safely letting the engine spin free without backdriving the motor. It's totally foolproof.
It truly is a phenomenal, highly choreographed combination of low-voltage electrical switches, electromagnets, helical splines, planetary gears, and fail-safe clutches. And all of it is happening in the blink of an eye. So I'll leave you with this final thought. Next time you start your car, will you